Hey kids, how are you? Yeah, I thought I'd do a little review. So today, a little battery action, no big deal. Let's make a series circuit. So remember the resistors, you got to go through them all. If you're this little electron fella, you're gonna go out and do a run a race. You have to go through both of them. Ooh, and make the full circuit. Nice. Now remember, if this fella has 5 ohms of resistance, and this one has, say, I don't know, 10 ohms of resistance, this one has more resistance than this guy. The total resistance in a series is simply, it's 5 plus 10. You just add them up. Boom, it's 15 ohms. Now remember, my boy Ohm comes with Ohm's law, V equal I R. And so something like this, and when you divide, lo and behold, you get, what do you get? 0.8, I believe. 0.8 amps. Hot diggity. Hot diggity. What does that mean? Everywhere you go in this circuit, doesn't matter where you're at, you're going to get zero point 0.8 amps of current. You're like, oh, that's awesome, man. Now, something that Mr. Groom mentioned yesterday, but I don't know, some people don't pay attention to me. People don't listen. It's like we got married and I'm the wife and no one listens to me. I don't know. I don't know what to tell you, friends, but whatever. It's all right. I'll probably get over it. I said to you, I said, listen, I said, could you push these people through this hole faster? And we agreed that if you motivated them properly, you could. Watch what happens. What if this was a 50-volt battery? But Mr. Groom, you said it would only be 12 ever in automotive. Yes, well, I wasn't lying to you. I just said simply, if you pushed harder, you would get a bigger current. So hot diggity, V equal I R. So 50 equals, again, 15 times I. And when you divide by 15, lo and behold, you get 3.333 amps is the current. You're like, whoa, that's a lot more current. That's because they're a lot more motivated than they were before, you see. Before, we were only pushing them with 12 volts, and now we're pushing them with 50 volts. Again, same passage, same thing. If you motivate them, scare them, what have you, they will move faster. And that is what's happening here. Again, in a series, all of the current must pass through all of the resistors. Whoa, not 3 of them, Mr. Groom. Literally, we're going to do 3 this time. Whoa, that's key. Okay, that's key. Nice. So the total is 8 ohms of resistance. So V equal IR. Bam, 12 equals 8I. And divide. And you get 1.5 amps of current. Bam, boom, done. Piece of cake, baby. Bam! Now, we also looked at some parallel circuits. Now, remember, parallel circuits are very bueno. We use them a lot in automotive, specifically for lighting. It would be goofy if you had a different bulb on the left side of your car than the right side of your car. So usually, almost without fail, you will see the same resistor on each one. And again, like we talked about yesterday, when the current gets to here, half's going this way, half's going this way. Why? Because everything's equal. So why wouldn't you? And then when you get on, they come back together again. Yay! Cute. Now, we also talked about this yesterday. If you have a parallel circuit, that's always going to be less resistance. And specifically, if it's the same 10 and 10, and you have 2 pathways, the total resistance is half of one of them. So in other words, 10 divided by 2 is 5 ohms. And so my boy Ohms would have said this. So 2.4 amps of current. Geez, I feel like I did this one today. I think I did. So 2.4 amps here. Half of it's going to go here. Half of it's going here. Bam. They come back together, and lo and behold, it's 2.4 amps again. Kaboom. Mic drop it. All right. Again, similar process. Listen to me. I'm from Canada. It's a process, Mr. Groom. You don't understand the process, Mr. Groom. That's right. Well, here it is, yo. What? Remember, we talked about this today. Are they all the same, Mr. Groom? I don't know. I haven't written them yet. Calm down, bruh. 18, 18, 18, ohms, ohms, ohms. Well, Mr. Groom, I feel like if you give me 3 choices, each individual, like Bob, might take this route across the top, Susie here, and Elena down here. Box office. What does that mean? There is a lot less resistance. How much less, Mr. Groom? Well, it's actually going to be 1/3 of one of them. Why? Because there are 3 branches and they are all equal. So 6 ohms is the total resistance here. And so, simply, it is 12 equals 6. I is equal to 2 amps. That means you're going to have 2 amps here, 2 amps here. But what's going to happen here? Well, I don't know. You're going to take 1/3 of it. So 2/3 of an amp, 2/3 of an amp, 2/3 of an amp. Oh, Mr. Groom, I got 0.6. Repeating. Literally, it's the same. It's literally the same. Good for you. Good for you. So these are the things that we are going to talk about in today's little assignment. Good luck.